Okay, so whenever you start a MATLAB window, and then when you start, and then you see that this is the file directory, like that's the file directory. So you see that Windows System 32. Like when you see that you started the MATLAB and then everything is on your Windows system. Like currently, that's where MATLAB is going to operate from. Like just know that whatever you do, you might not be able to work with it. So let me say something. So let me do this. Diary.
The second way is by typing end.
So you see, they said error using what? Error using diary. See, they said error using diary, cannot open file, permission denied. Do you get what I'm saying? Aha, let me try something. Diary on. Let me do this. Error using diary. You realize, so you have to change your file directory before you can be able to use the diary something. I want to address it right now because like a lot of people are raising comments and concerns on it. So you come to this place, the hard disks. So your hard disks, you see for your hard disks, you have a lot of stuff being stored. They come to users. So then users, so there's a public and then there is your user, like there's a public place and then there's a place for you yourself. So you select how you saved your PC. So with mine is my name. Then over here, wherever I want to store it. So over here, okay, I like to store it at documents. So when I open my documents, I already have MATLAB works there. So everything is there. So you realize that when I type diary again, so diary on, you see it comes, like you see it works. There is no problem with it and all. But then when I don't change the directory when I open my MATLAB, you realize that I'll be having issues with operating things in it. So that's the thing. So you just have to change your directory. Good. So that's one concern, dude. That's one concern. Then number two, yesterday's assignment. Let me share it. I realized that a lot of you didn't do the assignment. Is it that you know the sit-up or a lot of people didn't do the assignment? Oh, wow, what's up? I think I only saw like 4 people or something doing the assignment. Like, hello, oh, can we unmute and talk? Like, let's unmute, like, let's talk.
Oh, we'll submit it.
You submit. Well, I will actually work. Okay, but I'll just go through like activity 1 with you guys before we start anything. I'll go through together with you. So let me share my screen. Okay. Okay, so something like this. Oh, let me close this one for now. Okay, good. So this was the assignment. So it says that define the variables D. So we said D was what? D is 4.5, right? So D is 4.5. Then E is what? Can someone read for me? What's E?
2.8.
E is
2.8, right? Okay.
Yeah.
That's fine. Okay. So E is 2.8. All right, then what did the question say we should do? Question said use the vector. So they said that we should create a column vector with that variable, right? So a column vector F. So that's what the question said we should do with E squared D plus E, D to the power E and E. Okay. So now I said we should create a variable F. And then that variable is a what? It's a column vector that has what? That has entries. So the entries are E squared. So E cap 2. That's E raised to the power 2. We know that. So a column vector. So I put my semicolon there. Then the next element is D. So D, I put semicolon there. The next one is what? The next one is D plus E. Then the next one again is D to the power E. Then the next one again is what? E, right? Then I close the bracket, enter. So you see, this is my column vector F. So whenever you put the variables, like let's say you have defined some variable, like you have defined a variable and then you put it in a matrix. When you want to get the resultant matrix, what MATLAB does is that it will just simplify it for you straight away. So the same way, somebody will be like, oh, I don't want to use the semicolon. I want to go with my row and transpose. So F in that case would be, when it's 140, someone should tell me e to the power 2, then D plus E, then D to the power E, then E, close the bracket, then transpose. So you see, it's the same thing. Do you get it? It's the same thing, like nothing different, like nothing changes. Great. Then the next question we asked was, now use the vector above to perform the following computations. Element by element multiplication on the variable F. So if I want element by element, so element underscore element. So for element by element, how do we do it? How do we do it? F dot what? F dot star F. Do we get it? Do you understand? F dot star what? F dot star F. So enter. So you see, this is it. So I told you 1.0 E plus 0.3. It means that what? It means 1.0 times 10 to the power 3. So this answers we have over here times 10 to the power what? Times 10 to the power 3. Perfect. So that's it. Then the next one. The next question says that compute the mean of the variable F. So we want to compute mean of the variable F. So the mean underscore variable F will be equal to what? Mean open bracket F. I think the inbuilt function is mean, right? Nobody's minding me.
Yeah, it's me.
Mean. Okay, so
Yeah, we are here.
Yeah, here. All right. So mean underscore variable F, that's 17.984. Do you get it? So for the variable F, the mean is, this is the mean, 17.984. Then the next one says that sort the variable F. So sort means that list it from what? Lowest to highest. So sort open bracket F. And this one's, you will need, before you can do something like that, you need to know the built-in function before you can do something like that. Do you understand?
Please excuse me. Said we will need what?
I said we will need to know the inbuilt function, like the built-in function for the function that we are being asked to perform, or the task that we are being asked to perform. Do we get it?
All right. Yes.
So if it says sort the variable and then you don't know the built-in function, how do you do it? That's one thing about MATLAB. So with MATLAB, that's why there's a help button there, the documentation button are there. So whatever thing that you do, just go. Or even online, say, just type, how do I do this? So just come Google. So sort variable F. So sort, enter. So when I sort, you see, that's done it from what? Lowest to highest for me. Okay. Then the next question said, compute the standard deviation. So standard deviation variable F, that will be equal to what? STD open bracket F. So the standard deviation is what? 27.7331. Are we good? Are we good?
Yeah.
Did we get this? Like those of us who have tried it. So let me open. Oh, somebody say, you know, the setup. Oh, Charlie, it go be. Don't worry, it go be. It doesn't take 1 day. So let me download those who have sent DS and then check on it. Let me download those who have sent DS and check on it. MATLAB. Oosh. Okay, so there's Clement. Clement has already sent this. Then there is Gideon. And then there's Ebenezer. Okay, so new share. So let me share this one. Okay. So Clement, yeah, Clement was able to do it. Okay, that's fine. Element by element, he did that. The mean, he did it. He sorted standard deviation. Perfect. Good work done, Clement. So Gideon, fish. Ebenezer to the same. Okay. All right. Mean, sort. I hope you can see their work. I hope you cannot see their work.
Yeah, we can see.
Okay. Standard deviation to all right. That's great. That's great. So people are doing it. People are doing it. Oh wow. Which app did you use? Is Gideon here? Is Gideon Opoku here? Gideon Opoku, if you are here, kindly mute it because this looks different. I want to know if it's the phone app or which app did you use to do this, because this looks different a little. Which app did you use? Did you use the phone app or use the online?
I use the online one.
Use the online one, and this how it generated it for you when you printed it.
No, like I couldn't generate, so I had to type it.
Or you copied it into Word?
Yes, no, into latex.
Into latex. Okay, that's fine. Yeah, so people are doing it. Thank you very much. So f.f, okay, this is fine. The mean, sort out, standard deviation. Perfect. So those who have submitted their works, like good work done for the first part of the assignment. Good work done. Let me check if I downloaded everybody's work. Yeah, I downloaded their works. Ebenezer, Clement, I downloaded it. Okay, fine. That's great. The next question. Next one was like activity B. Create a vector W, 41 is to negative 3 is to 29. Then W is 17 is to 4 is to 37. Then by only using the name of the vectors V and W, so we are only required to use V and W, that's all. Create a row vector R that is made from the elements of W followed by the elements of V. Then create a column vector that is made from the elements of V followed by the elements of W. Then create a matrix M that is made from the elements of the first row W followed by the elements of the second row V. Great. So let's get to that. Okay. So with this one, we are being asked to do something. So activity 1B. Okay. Let me leave someone more space, then we can go. So the first one was like V is equal to what? V is equal to 41 is to negative 3 is to what? 29, right? And I said you can ignore the brackets. Like you can ignore the square brackets. That's for this particular type of computation. You can ignore the square brackets. I said, c'est pas better. So W. So W is 17 is to 4 is to 37. So that one, yeah, I don't see the output for now. So the first one was saying, create a row vector R that is made from the elements of W followed by the element of V. So I want to create a what? A row vector. So when I want to create a row vector R, what will R be? R will be what? Let's try this. I want to create a row vector. Anybody online, kindly give me what I will do. Okay, I'll start calling names.
You just put.
Great. Let's go. I should just put
V and then you use comma. You wouldn't have to use.
Great. So V, comma W or enter. So you see it has come as a rule. Or R again is equal to V space W. Sorry. R again is equal to V just space W. That's all. Enter. So everything is there. Then the next one says that create a column vector C that is made from the element V. Oh, I want to do W followed by V. I failed the example. So R is equal to W followed by V. I failed the example. How? So it's supposed to be this way. So the next one was like, create a column vector C that is made from the element V followed by the element W. So how do we create this one? Let me call somebody from the chat to do it for us. Jerry, the shy boy. Yeah, Jerry. Yeah, Jerry says he's a shy guy. Jerry, please show us. Jerry, please show us. How do we create a column vector? Yeah, Jerry, show us. Hey, Jerry, don't brown me. Please don't brown me. Don't brown me. Jerry, please don't brown me. Maxwell, how do we create a column vector? Oh, you are typing. Oh, okay, you are typing. Oh, I wanted you to unmute and just go ahead straight so that we could move faster, because when you are typing, I now have to come and click chat and then see what the person has typed. So if you can unmute and see it, I'll be very glad so we could move fast.
Hey, Shy.
Yeah. Jerry, what do we do?
So,
we didn't hear you. Did somebody
Yeah,
hear
so
Jerry?
separate the columns by a semicolon when you're inputting the elements to go into the array. For columns to be separated by semicolon, so you input the data for that column, then a semicolon, then for the next column, the data, then a semicolon,
Okay.
all in a square bracket.
Okay, that's fine. So let's try that to see if it works out. So Jerry is saying we should do vein semicolon W. Jerry, this is what you're saying that we should do, right? What I've done here, you said we should do this, right? Okay. So this will not work out. Why am I saying this will not work out? This will not work out because vein is a row. Do you understand? Vein is a row. So it will not work out. So if I put it this way, what is going to happen is that we will get vein as a straight row, then W is right under vein. So we'll have two rows, and that's a matrix. And we don't want to form a matrix, but I want to form a what? We want to form a column vector. So what we can do is that this is what we can do. So the first step is to do is that we can just do vein W. We have a row, right? Then we transpose the row, easy. Then we've gotten this. Do you understand? So that's the first step. That's the first thing that we could do. We could create a row for both of them, like create a row together. Then after we are done, they will just transpose everything quickly. Or also what we can do is that we know that V is a row, W is also what? A row. So we can just do transpose V space. And we know space, yesterday I explained space, that what? Space means what? Space means free flowing. Do you get it? Like it should flow, like it should continue. Do you get what I'm saying? So space, it should continue. So continue with what? Continue with W, transpose. Do you understand? Close the brackets, enter. Hold on, invalid expression.
you have to use a
Yes, please.
semicolon.
Yes, please.
The semicolon, yeah. I have to use the semicolon. So vein. Perfect.
But you were mentioning the space.
I was thinking of that because I was thinking of the fact that when you just do the space, it just tells it that continue. Do you understand what I'm saying? But then in this case, you are dealing with columns. Actually, we are dealing with columns. So the column must come in. That's if you want to go this way by transposing them, then the column must come in. But then if you want to go with the normal way, create a row, then you transpose it, that one, then that's where the space will come in. Do we get it?
But the one you just did, there was no spacing. Or
Which one?
the V transpose. C is equal to V transpose. V W transpose. There's no space there.
I'm coming. Let me try that.
The red one, the one in red. See.
The red one. Hold on.
Bracket. Yes.
MATLAB automatically. I'll come. Okay, so dimensions of array are not consistent. Yeah, they're not.
Okay.
Okay, they only, but they are the same. Hold on. Wait, let me generate results for vein. So vein, comma W. Let me just generate results for that. Okay, they are not consistent. Okay, in the case they were consistent, then that would have worked out, but they're not consistent. All right.
All right.
All right. That's fine. Next one. So now create a matrix M. So creating the matrix M, that's when we will do the first row, W, then semicolon, V. Do you get it? So I just telling MATLAB that move the V to the next one. So then in that case, the matrix M will be what? W, V. Wait. Okay, these ones are not consistent, so I need to add one. So you see, the only way we can create a matrix is what? Is when they are consistent. Do you understand? So if we have the same number of terms for a row, the same number of terms for another row, then it can work out. Great, great. So let me check. Let me check what we did. Let me check what we did. Okay, that's fine. That's fine. Very soon it will be 140, then we can start. Okay. That's also great. All right. Oh, so people are doing well. 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 That's fine. About says 4 minutes more. So let me solve the last one under activity one. So under activity one, the last one is, hey, Emmanuel, you want to ask a question? Feel free. Emmanuel, let's go.
Yeah, so my question is, for that particular area where the two vectors weren't compatible, what if you decide to add, maybe increase the other vector that had only 5 elements, and then maybe go on with the question? What about
That's fine.
that?
That's fine. We can do that. We can do that. We can do that. That's fine. So what element are we going to have to add there? What element do we want to add there? What element do we want to add there?
So in this case, I added something like 29. Was it 26? Yeah, 26.
You added 26. Okay. So that will be V of 6, right? It's equal to 26. And
yeah.
So enter. So we have this. Then you continued with it now. Okay. So M is equal to open bracket V column W. That's fine. That's also great. So then this one, then you should just put an activity there showing that what you did that. Do you understand? So so you can just put the percentage sign since the arrays are not compatible. Like, do we get it?
Yeah, yeah.
So since the arrays are not compatible, (26) was added to V to form a matrix.
Okay, okay.
Enter. Okay, so let's solve the last one. The last question is just one question, I think. Then we can move on with today's work. So there's activity 2, there's activity 3, there's activity 4. So we can finish that. So I just wanted to go through this one so that at least people will see that, oh, the work is not hard. It's easy. Because sometimes when you see a lot of work like that, people just think it's hard work. No, but not too hard work. So create 2 column vectors T, 5:5:25 transpose S, 27:2:33 transpose. So let's create that. So they said we should create what? T, right? So activity. So activity 1C. So it said T is equal to what? T is equal to 5:5:25 transpose. So this one I want us to see that we've been able to do it. Then the next one says that S is equal to what? S is equal to 27:2:33. Okay. So we have 27, 29, what? 33. Now the next one says that what? Create a column vector R that is made from the elements of T followed by what? The elements of what? S. Do we get it? So for this one, how would it be? So this will just be what? We should create a vector. Did they tell us to specify the vector's name? Column vector R. So R is equal to what? Square bracket open T colon what? S. So everything is there. I hope you are good. So you see, it didn't take us, I think it took us how many minutes? Just 20 minutes, 25 minutes. We are done with number one. And even this one is because I'm explaining it to you people. So imagine you are doing it on your own. Roughly, it should take like 15. Okay, somebody say I'm a pro, so it's okay. So if somebody say, oh, you know what, you're a pro, you're the one teaching us, so that's why. Okay, you have a point too. But all I'm trying to say is that, like, it's not hard work. Like, let's just put in our all. It's not hard work. Let's put in our all and let's learn the skill because it benefits us on the long run. Yeah. Okay, next one. So let's move on to today's lecture. Let's move on to today's lecture. Okay.
Yeah.
Why was someone asking a question?
Oh, no, it's okay.
It's okay. Are you sure?
Yeah.
Okay, that's fine. That's fine. Okay, so today I come to do something we call symbolic math. I think I gave the course outline for how we'll be studying the MATLAB, right? Yeah, let me open it. Let me know if I'm on the right side. Yeah, symbolic math. So today is symbolic math. Tomorrow we'll go through some numerical methods, differentiation, integration, ordinary differential equations. We might even do all of them today, but we'll do it in the symbolic. We'll do some in the symbolic math, then we'll do some tomorrow too. Yeah, we'll do the symbolic math part of differentiation integration. Then all these who are very interested in that, MATLAB graphics, polynomial and curve fitting. Then finally we'll do the programming aspects. Okay. So today symbolic math. So the reason why I decided to teach matrices first before doing the symbolic math is because if I do the symbolic math first, you will not see the reason why I should take the matrices seriously. I mean, a lot of you are going to be like, so why was I stressing to do this metric something? Like, it's not really worth it. Like, when you have symbolic math in MATLAB, it just makes life very easy for you. Like, life becomes very, 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 very easy. Like, super easy. So let's go on. Okay, so today, again, we are coming to study symbolic math. So you see, as I said earlier, what MATLAB does is that MATLAB just provides you an interface that enables you to work with what? Just matrices, vectors, and arrays. You realize that when we are doing a differentiation and integration, that one we will have to input some functions and all. We'll study that tomorrow. Like we'll have to input some functions and some little things. But most of MATLAB work, even with the functions, even when you put a single number in MATLAB, we said a single number is a what? That's a single array. Do you understand what I'm saying? So even that is still a matrix. Do you get it? It's a matrix of what? A matrix of one row and what? And one column. Do you understand what I'm saying? So that's how MATLAB works. MATLAB works with just matrices, arrays, vectors. That's how it works. But then it's not too interesting. Like it gets limited. Like it gets very limiting when you're supposed to do something very high work or high quality something. It gets very, very limited. So then in that case, then they brought about something called symbolic math. Do you get it? Symbolic math. So that gives us the option to like solve X and Y stuff straight away in MATLAB. Like we're able to solve some X, some Y, oh, do this, do that. Then it's able to work out. Okay. So I hope we get what's going on. All right. So as I said, all mathematical operations so far done are numerical, but many applications require symbolic operations, as I said. So it requires, like, it's very limiting. Like the matrices and those things, they are very, very limiting. So symbolic operations can be performed by MATLAB using the what? Using the symbolic toolbox. So before I continue, let me share my screen for this one. Let me share my screen for that one. Let me download this thing first before I. Okay, so now I can do CLC. So I hope we have our MATLABs with us. Yeah, it's a moment. I'm back. So we have our laptops with us. Now, so the whole symbolic toolbox something, when some of you were installing your MATLAB, some of you will not be able to perform, this part of MATLAB on your window because you didn't install the symbolic toolbox. So what do I mean? You only just installed MATLAB. So meaning you can just have your matrices and all. But when you type sims, like sims, so if you want to do any symbolic something, it's just sims what symbol? Sims A, sims B, sims C, sims X. Do you get what I'm saying? Then you press enter. So if it works, then it means that what? If it works, then it means that you can continue. But then when you type your sims A, B, C, D, X, or sims D, G, whatever, like symbolic math, whatever, and then it gives you an error, it means that you have to install the symbolic toolbox. Like you have to get the package for it on your MATLAB before you can be able to run such computations. Do we get what's going on? Okay, so I hope we can continue now. Yeah. All right. So symbolic math. So several symbolic math can be created in one command by the sims command, as I said. So you can just create, as I just did earlier, like sims. So whatever thing that you want to create. So sims A, B, C, D, X, sims K, sims E, sims F, sims whatever you want to work with. Sims, then you move on. All right. Sims that thing. Then now, once symbolic variables are created, they can be used for creating symbolic expressions. Okay, so like there's this example like this, sims A, B, C, D, X, Y, and then there is what? F is equal to AX squared plus what? BX plus C. So let's create something like that. So we have sims A, B, C, D, X. So we want to create a variable. So variable Y is equal to, say, A. So we can do the A times X to the power 2 plus B times X plus what? C. So you can see Y is equal to what? AX squared plus what? BX plus C. So you can create other ones. Sims half, sims M and V. So we want to create an expression for kinetic energy. So kinetic energy is equal to what? What was kinetic energy equal to? I think 0.5. That's half times what? Times mass. Now use small m times velocity squared. Enter. Oh, come, let me use this one. K dot E is equal to 0.5. Hold on. Star M star V squared. Oh, what's happening? Okay, hold on. Okay, let's do this. What's going on with my math?
Hello, I think it's because of the K dot E.
Hold on, I'm coming. Hold on. So it seems, let me do this. MV. So I have half star M star V cup. Okay, I see. So it's a dot. All right. All right. So then the next one, so we can create more expressions. So sims, we can create more and more expressions. Like someone should give me an expression in your course. So biomedical, give me one expression in your course. Okay, so for chemical engineering, I know they have something
E
like
equals MC squared.
E equals MC squared. Okay, so MC. That's fine. So E equals what? E equals M star C cap 2. equals mc squared. So in chemical engineering, there's something like what's the name? So rho. So you can represent rho like so rho, there is velocity, there is diameter, and then there is mu. So you can do something like that and say the Reynolds number is what? The Reynolds number is rho times the velocity times d divided by what? Mu. Great. So you see, so that's what, so like that's the advantage that symbolic math gives to us. It gives us the platform to feel free and express ourselves like arithmetically, like analytically. That's the platform that symbolic math gives to us. Yeah. So I hope we can continue now. So the next one. Okay. So now symbolic expressions are created by the user or by MATLAB as the result of symbolic operations. What. So in symbolic math, we can do some various things. Number one, we can collect, we can expand, and then we can factor. So it's just like math. So when you collect, you are collecting terms with the same power. When you expand, they're expanding products. And then when you factor, we are factoring out multipliers, like some of those stuff. So we'll do them, then you see. So the collect. So the collect command collects the terms in the expression that have the variable with the same power. Then in the same expression, the terms will be ordered in decreasing order of the power. So let's say you're asked being, you are being given some small polynomials, and then they tell you that, oh, using the symbolic math, like let's say perform operations such that it will be in decreasing order. So in decreasing order, you know that you have to use what? The collect. When you use the expand, you might not really get the same answer. But then when you use the collect, you know, so what does collect do? Collect does what? Collect, like it gives your results to you in terms of what? In terms of decreasing order. So now you know S is the what? S is the variable. Do you get what I'm saying? Yes. So let's try that. Let's try that. You share. So Sims. So let's say Sims A. Great. So now y is equal to what? Y is equal to, can somebody, so let's say a squared plus 2a plus 2 multiplying what? Is a cubed plus 3a plus 5 multiplying a to the power 0.5. I want us to try adventurous things. Things that we've not seen, things that we don't do in our test. Plus 1. Then finally, let's give a last one. A plus 2. So enter. Oh, okay, yeah. Did you mean that? Yeah, I meant that. So now we have this. So now we say, so let's say Z is equal to collect, open bracket, Y. So collect Y. Okay. If you have collected Y, so collecting Y, see how it has given us the answer in terms of what? Descending power. So this a to the power 6, this a to the power 5, this a to the power 4. So what it has done is that it has just factored out the a to the power half out of each of the expressions. And then a to the power 6, a to the power 5, a to the power 4, a to the power 3, a to the power 2, a to the power half, and a constant term. Do you see that? Like, do we see that? So we can try another example too. So from the slide, there was an example that says that x minus 2, x plus 3, x plus 1. I think that one we can relate with that more. Yeah, so seems x. So y is equal to what? Open bracket, x plus 2, x minus 3 times what? Let's say x plus 4. So collect. So z is equal to collect y. So decreasing powers of x, x cubed, x squared, x, and then the singleton. Somebody had asked a question. Why didn't you include y and z in the current sims, but instead of a only? So I didn't include them because they are variables. Like I'm defining their variables, but they are not needed in the symbolic expression. You understand? This is the symbolic expression. Yes, they are not needed in the symbolic expression. If I add them in, then it means that what? They are then involved in the symbolic expression, but those are variables just to represent the symbolic expression. Do you get that? Do you understand that? So that's the reason. Yeah. Okay, that's fine. So then the next one. So expand. So what expand does is that expand carries out product of terms that include summation, used at least one of the terms, and then it uses trigonometric identities, exponentials, what. So expand. So what expand will do is that this is what expand will do. So you're supposed to do this one. It will just carry them out in terms of summations. You understand? Using at least one terms. So this is what expand will do for us. So you see what I was saying. When you use the collect term will just give it to you in terms of increasing order. But then with the expand, you see that it doesn't really matter the order. It just gives you the answer. So that's the difference. So just do the difference based on what you want. Then you can perform the computation. Okay. Then there is factor. So factor, we know what factor do. So you are supposed to factorize something. What to factor do? It would factorize it for you. Do you understand? So the factor command changes an expression that's a polynomial to a product of polynomials of lower degrees. So that's what we're like factorization in SHS, in GHS. That's what factorization does. You get it? And then there's also simplify. So simplify also does simplify would. So you have simplify like this. So you have something like this, and then you are supposed to divide something by something. You can use the simplify command to do so. All right. So let's try our hands on something. Let's try our hands on something. Come, I forgot to say you guys this thing. No, not this one. Ish, did I close the whole thing? Ish. Please hold on, I'm coming in. I want to close all the documents. Okay, so I've opened the symbolic math back. I think I was supposed to open something for you guys. Yeah. I was supposed to try some questions. Yeah. Okay. Good.
Blues.
Yeah, I'm coming. I know I'm not sharing my screen. I'm coming. I know I'm not sharing my screen.
Yeah. Okay. I wanted to ask a question.
Yeah, feel free.
What did you say was the difference between the collect and expand?
The what?
Because the collect and expand.
What they do is that they do the same thing. But then one of the differences is that what collect does for you is that collect will just give you the answer or your result in terms of decreasing order of x. Do you get what I'm saying? But then for expand, it can just give it to you in any order. Do you understand? That's one thing.
Okay.
Yeah, so let's try A and B. Let's try A and B. So use MATLAB to carry out the following multiplications of polynomials. So this one like this, we're not giving what to do. Like we're not giving in decreasing order of x or in anything. So you could use expand or you could use what? Collect. Do you understand what I'm saying? Do you get it? All right. So I'm coming. Let me share the MATLAB screen. Okay. Let me not delete this. So that let me not do CLC. Yeah. So Sims what? Sims X, right? Sims X. Sims X. Then what's the next step? Then the next step is use it to carry out the multiplication of the following polynomial of x, then x plus 1.8. So we have y to be equal to what? X multiplying what? X plus 1.8. Then multiplying what again? Then multiplying x minus 0.4, x minus 0.4, multiplying what? Multiplying x minus 1.6. So we don't see this, so we'll suppress it. Suppress. So now the first one. So they said that we should do what? We should just carry out that computation, right? Yeah, carry out the computation. So in that case, we can use what? Expand or what? Collect. So let's use both. So z is equal to collect, open bracket, y. Enter. So we've seen the answer. Then let's do a is equal to expand y again. So you can see. Hello, are we here? Hello.
Yeah,
Yeah,
we are
yeah.
here.
So you see, we had the same answers. You see, we had the same answers. We had the same answers. So anywhere at all that you could do, you will get the same answers. Aha. But the problem with expand is that when you have different terms in now, then when you have different terms in, then in that case, it wouldn't give it to you like in a descending order, like this. But then because it's more or less like the same term, that's why it's like that. Okay, next question. The next question says that use MATLAB to divide the polynomial minus 9x cubed plus 12x squared plus 5x to the power 4 minus 9x cubed. Let me share this screen. Oh, I just remembered I could do something. All along, I was fooling. Hold on. Let me stop sharing. I just remembered I could do something. Let me. Please, I'm coming in. Great. Now let me open my Zoom. Share. So Zoom cannot share splitted screen because I want to split my screen here. Oh, because I wanted to split the screen. I think we just have to go with the normal way now. Okay, sure. Have I been able to split my screen?
Yes.
Yes.
We can go. So like this, we can be able to follow through. Then we can understand what's going on. So I think we'll be doing this week. We'll be doing it this week. Okay. So the next question was like, use MATLAB to divide this polynomial minus 9x to the power 6 plus 12x to the power 5 plus 5x to the power 4 minus 9x cubed plus 17x squared minus 9x minus 15 by the polynomial 3x squared minus 2x plus 3. Great. So with this one, Sims X again, right? Sims X, right? Then we have what?
Yeah.
Then we have our polynomial. So y is equal to what? Y is equal to minus 9x to the power what? 6 plus what? 12. Hey, am I typing? Plus 12 times x to the power 5.
Plus 5 x to the power 4.
X to the power 4. Okay. Minus 9
x to the power 3.
X to the power 3. Okay, what else?
Plus 17 x to the power 2.
x to the power 2. Mhm.
minus 7x
Then minus 15.
minus 15.
Right? Okay, so suppress that. Then z is equal to what? 3x squared minus 2
minus 2x
minus
minus
2
3.
minus 3. Right? Minus 3. Okay, that's fine. Suppress this 2. So we want, let's say Jane. So let's say s. S will be equal to what? Simplify what? Simplify. So what do we do? So what do we do here? Oh no, I forgot something. No,
You just
no,
okay.
hold on. Come. I should have just made it, let's say s straight away is equal to, then this one, that's this one. Copy this one, Control C, come and put it here, divided by that. So you simplify, you just insert the expression there straight away, then Control V, then suppress it. So now simplify. So then is equal to, yes.
Shouldn't you have placed the numerator in a bracket or something?
Well, okay, let's try it and see. Well, let's try it and see. So simplify S. Now, So yeah, so what you're saying is right. I should have placed the whole numerator in the bracket. That's true. I should have placed the whole numerator. So W is equal to, yeah. Because you realize I didn't simplify it for us. I don't know. I think it performed another computation for us. So we put this in the bracket. This whole bracket is something MATLAB. I'm just not a fan of it. No, I normally perform the computations without the bracket. So I'm used to that. Lifestyle. Control C, Control V, close the bracket. Okay, close the bracket. So J is equal to simplify. No, let's not use J. Capital U is equal to simplify. Simplify what? W, right? Capital W. Great. Do we get it? Do you understand? Hello? Are we here?
Yeah.
We are here,
It's
right?
okay now. Yeah.
Okay, all right. Okay. So because we know that, of course, when you divide x to the power 6 by x, we are supposed to get x to the power 4. So the first one just made me realize that I think it just did, I don't know how I performed the computation. I'm sure the way I placed it in, that's the problem. Yeah. Yeah. So now, have we seen how the simplify works with the simplify, the collect, and then the expand? I hope we've seen how they work, right? So we can continue. Okay.
Bluey,
Yes, talk to me.
I thought if you execute it was going to simplify it straight away. But then when you entered the expression.
Which one?
This over that.
Was it the first time I did it? The first time I did the S?
Yes. Yes.
So the problem is that
here. From the W.
From the
I
W.
thought it was going to simplify it if you just execute, if you just press enter.
No. It won't execute it because you've just imputed a symbolic expression. Do you understand?
Okay.
Do you get what I'm saying? That's a symbolic expression that you've imputed straight away. So now if you want to execute it, there are various functions, there are various commands, and there are various functions that you have to use. Let's try it. W is equal to this. Then let's press enter. So let's not suppress our output. I think we should be doing the class this way. We split the screens. Or what do you guys think? Then press enter. So you see what it has given to you. It just gave you the answer like this. Sorry. It just gave the answer like this. Just give it as an expression. You see, it didn't simplify anything. That's what it will do. Please, I hope you are here. I hope you are
Yeah.
here. Are we
Yeah.
fine? Okay.
Yeah, we good.
So the first time, what I wanted to do was, I wanted to do the first one, like J is equal to simplify. I don't know if this will work. Y over Z. Enter. Great. So it worked. So it worked. So what somebody can do is that somebody can also do it the way I did it the first time. Just do Y and Z. Do you understand? Put them as different variables, Y and Z. Then when you get there, just simplify Y over Z. That's, you know, that you're supposed to, if you want to divide, you have to use simplify. So in that case, I think you can try capital Y is equal to expand Y times X. Do that. You get that. Are we here? Are we here?
Yeah.
I hope you are here.
Yeah.
That's great. That's great. That's great. Am I sure I had the right expression? I don't think this is right. Because this expand, this answer there. Hold on. Let me do Y. Let me do V is equal to collect open brackets Y star X and see if I get the same answer. Okay. Then maybe I'm the one overthinking. All right.
Yeah, I have the same
I'm going to use
thing.
X. So you see one thing about MATLAB, I'm going to use X. No, I think we've already just X, just normal X. Charlie. E is equal to collect. When I name them as Z and star Z. Okay. This was what I was looking for. This is what I was looking for. Minus 27, X power 8, X power 7, X power 6, X power 5. That's fine. That's fine. That's great. That's great. Okay, so now we can continue, right? Yes. So now let me go back to the lecture notes. Let me go back. Okay, the lecture notes is right here, so it's fine. All right. Can you post still see the lecture notes? Can you post still see?
We can.
You can still see.
You
You can
can
see.
see.
Can see.
Okay, then we can continue.
You just had to zoom in.
I just have to zoom in a little.
No, we.
Oh,
So just
okay. Okay. So solving algebraic equations. So what the symbolic math gives, the advantage it gives to us is that it gives us the advantage to solve algebraic equations. And then we could solve algebraic equations for one variable. You see that when you're using the matrices, you have to first express them as coefficient matrix, result matrix. If you want to use left division, you have to transpose, right division, you have to do this, you have to, it's work. With matrices is work. But then with the algebraic equation, you can just put the equations in straight away. Then MATLAB will just solve them for you straight. No need to do anything there. It's just solve it for you. Great. So we can try that. So, and then when we are doing algebraic equations in MATLAB, one thing is that one thing that we do over here is that when you don't equate the equation to 0 and then you say solve. So over here, you use the solve command. When you are solving algebraic equation, use the solve command. So when you don't equate it to 0, and then, or when you don't equate it to something, and then you just put and then you actually just put it there, it will equate it to 0 and solve it for you. Do you understand what I'm saying? So let's try that. So you have something like that here. So let's try it. So let's say Sims. So let's give an example, Sims X quickly. So y is equal to, say, y is equal to x squared plus 2. Let's do this, x squared plus 2. X squared plus 2, something quickly. We are done. Y is equal to x squared plus 2. Solve y. That's all. So you see, if you just equate y to 0, it will assume that what? We are equating y to 0. In MATLAB, when you don't add, it's equal to, And then over here, we'll not add just one equal to, we'll add double equal to. Why we add double equal to? Add double equal to because you're supposed to differentiate that, oh, this over here is a variable from it being equated to something. If we use one equal to, it means that this variable is equal to this variable, which is equal to whatever that we are saying. Do you understand? But then when we use the double equal to in this place, the double equal to just shows that, oh, our variable here is equal to an algebraic equation, or our variable here is equal to what? A linear equation, or a polynomial equation, or an equation. Like this is not a normal, like this is not anything normal. Do you get it? So when we solve,
Can you take it one more time?
can I take it one more time? So what I'm saying is that now when I come and do y is equal to x squared plus 2, and then when I don't equate it to anything, what MATLAB does is that MATLAB assumes that this is what equated to 0. Do you get it? And then solve y. So you see that solve y, as we invocated, you realize that it just equated this to 0 and then they just solve. So you see that this is what? Minus root 2i and then what? Positive what? Root 2i. Do you get what I'm saying? But then in the case where we are supposed to equate, you're supposed to equate it, you're supposed to use two equal to signs like this. Y is equal to x squared. Sorry, y is equal to x squared plus 2 double equal to, let's say, -4. Do you understand what I'm saying? We are supposed to do this. Why? If we don't do this, and then we put 1 equal to here, what you are telling MATLAB is that variable y is equal to another variable, which is equal to -4. So which one can MATLAB differentiate now? Do you get what I'm saying? You let me press enter for this. You see incorrect use of the what? Operator of the equal to operator. Assign a value to a variable using equal to and compare values for equality using double equal to. So you see, once you want to solve something, once you want to equate the left-hand side of an equation to a right-hand side of an equation, it must be what? Double equal to. Do we get what I said? Saba, do you understand now?
Yes,
Saba,
yes, please. I get it. I get it.
Okay. So now x squared plus 2 is double equal to that. So now let's see, solve y. So this is the answer. So you realize that if I taught symbolic math first before the matrices, you will not see the reason why you should learn the matrices, because you know what, symbolic math can just do everything for us. So why do we need to learn the matrices? So that's what I'm saying. It's like you will not feel the need to use matrices again. If you want to do something involving symbolic math, you just go ahead and do symbolic math. So that's what's there. So that's how we can solve algebraic expressions using symbolic math toolbox. To the next one. So solve exp z to the power. So there are various examples here. Solve this. I'm coming. Let me go through the tutorial and see if there is some question. Then we'll all do it together. Yes. No, this is polyfitting tutorial. I'm coming. The questions that are very advanced. They are not for today. Hold on. Can you guys see my screen or something? Hello, can you see my screen? Can see.
Yes.
Yeah.
All right. Okay. So let's try an example. Someone should give me an equation quickly. Then we'll solve it. An equation quickly. Okay. Okay, so say Sims A. So R is equal to sine x squared, right? So sine open bracket A, that expression squared, plus cos A minus 1. So double equal to 5. Let's do this. enter. So this is our expression now. So solve R. So this is the answer. So cos inverse of this, cos inverse of that, cos inverse of this, cos inverse of that. That's the answer. Do you get what I'm saying? So you can use this to solve your differential equation.
Yeah,
And you, yeah. Hello.
yeah, sorry to interrupt.
Oh, feel free.
I
Feel free.
wanted to ask a question on it. You see that before we start anything, we define our we define our variables, sims A, sims X, and all, yeah. But then I was trying something. Should we neglect that intro? We'll still get our answers, right?
No, you
So
not
if that's
get.
the case, why do you?
You know, you don't, when you, okay, let's do this. Let's say we do R is equal to that. You mean that, like, if we don't type sims A, will we, and then we just come and say R is equal to that, solve R, are we going to get our answers?
Yes.
Is that what you mean?
Asking.
We will not get our answers because MATLAB cannot identify this. So let's see. So let me just paste it here. Then enter. Then say solve R. Okay, hold on. Let me do CLC. Let me do CLC and start all over. Let me save this one. Sorry, this is D3, right? Ish. Okay, so now CLC. Let me clear my workspace. Now let me do this example. So B is equal to x squared plus 2x plus 2. Enter. Then solve B. It worked. I'm very shocked. Wow. This thing worked. I don't believe. Because there was one time I tried it. It didn't work. I'm very, very serious. There was one time I tried it and they gave me an error like unrecognizable function, whatever. Unrecognizable function X. So I've always been using this Sims until today. I'll try it in the evening again and see if it works.
All right.
Why did you just do it and then it worked out for you? Or you just asked the question?
Yeah, I tried doing it to see if it will work.
Okay.
Yeah.
Because for me personally, I always use the.
Yeah, I was trying. So I wanted.
Yeah,
because it worked without the Sims, I wanted to appreciate the why the Sims.
To why the Sims. Because for me personally, when you type in the Sims there, all you are telling MATLAB is that you are coming to work in symbolic toolbox, like symbolic toolbox activated. Do you understand what I'm saying? Okay. I've never, seriously, I've tried this thing before and it didn't work out. I don't know why. Like my early stages of learning MATLAB, I tried this thing once, it didn't work out, and I didn't try it again. But beginners, yeah, it's fine. Don't worry. Yeah, thanks, dude. Yeah. All right. Emmanuel, go ahead. Go ahead.
Yeah. My question is, if we go back to the ones we just did, with a sign and a cos, okay. Our final answer. I was thinking maybe we are looking for maybe the answer for A. Do you get it? But our final answer still had A in them.
Maybe why? Hold on. Let me go to where I saved them at. Okay. All right. You see, our final answers had what? A in them. Hello, Emmanuel.
Yeah, our final answers still had A in them. I thought maybe
the A there means cos inverse.
A means cos inverse.
The A cos is cos inverse.
Yeah, I get it.
Uh-huh.
Oh, okay. Okay.
Do you understand now?
Oh, okay. Yeah,
Yeah.
I get it now. I get it now.
The A there means cos inverse. Let me expand it so that we can see clearly. A there means cos inverse of that expression. Do you understand? It
Yeah, I get it now.
doesn't mean that A is part. Next person, I think Samuel, go ahead with your question. Samuel, go ahead. Sammy, go ahead.
Okay. I realized something. You see,
Yes.
if you don't use like based on the previous question, like the question before this question, based on the previous question, I also decided not to use the sims, but then to change. But then I changed the A to B.
Okay.
And then yes, and then I just wrote solve B, and I had the answer to be 0. So how different is what I had to the previous one when you don't use sims?
Okay,
Because
yeah.
I
So give me
realized
the
that
example. Yeah, give me the example. Okay, we are almost done with the class. That's why I'm asking a lot of yeah. So give me the example. Give me the example.
the example is our previous example now. The sign into brackets, but this time around I made it sign into brackets B.
Okay, so you did
everything raised
Sims.
to the power
So you
square.
did Sims A. You did Sims A, right?
I did Sims A, and then on the next line, I didn't do Sims. I just wrote the expression, but instead of the A, I placed B there.
B
Then I
there.
said solve.
Solve R, right? So let me do that here so that we all see. Are you guys getting the questions that people are asking?
Quite.
Quite. So what he's saying is that he did Sims A, but then instead of he did Sims A, then he came to write B here. Do you understand? Oh.
I wrote solve B.
Hold on. I'm coming. Try to get where this is coming from. Hold on, let me check this piece and see. Okay, it's fine. And then you wrote what? B, right? And then it says solve B.
Yes, solve B.
I think have I already used the B somewhere? Have I already used the variable B somewhere into this class? Where MATLAB is picking the expressions from. Come.
Yes, you've used the B. When you look at your workspace, where your workspace is, the place where the names are.
Yeah,
there is some
because I'm coming. Let me close this doc. There is a B there already. Yeah. That's why things seem to be messing up like that. I don't know why. So, I don't know where this answer is coming from, dude. Coming. Because this B here, it looks like I've used the B to relate this way. So you just solve for this. Okay. So even if I put solve for R there, it would give me the answer straight away. You see, but it's not supposed to come. Okay. Let me close my MATLAB and reopen it. I think that will work. Let me just shut everything down and reopen it. But in any case, someone had a question too. Aside someone who had a question. Aside someone who had a question. Aside someone, Abbas, go ahead. Abbas.
What I was trying to say is the one he just
We can't really hear you. Okay.
hello.
Yeah. I'm listening to you.
Yeah, what I was trying to say is I tried what you said, but I had unrecognized value, like let's say X.
Because yes, because
That's
I
what
know it's
I had
supposed to be
when I tried.
good. Because I know I've tried that thing before. And then it gave me an unrecognized value. Or maybe because I didn't clear my workspace.
Because
I'm sure probably it's because hold on. Let's do that thing.
your command was true. Yeah, that's why. That's what I
I'm
saw. Your
probably sure I
command was
didn't.
true because you've
Yeah.
already defined B.
Yeah. So let's say x squared.
Yeah, it's true. I also got unrecognized function. I used a new variable altogether. This time around, I used O, and it said unrecognized.
So I'm sure it's from the fact that I didn't claim my XPs from the very beginning. So B.
Exactly.
You see, unrecognized function, what? X. So unless we put the sims X, when the sims X comes into play, then A is equal to X 2 plus 2 times X plus 2. Then in that case, it works out. But then once, yeah, so it's because I didn't clear my XPs. Damn, I should have done that. Okay, thank you very much.
Bruce,
Go ahead.
Bruce, you haven't divided your screen. We are seeing just one.
You are just seeing my MATLAB screen. Oh, okay, I've not divided it. Hold on, let me reshare the thing. Let me reshare the screen. Can you see both of them now?
Yeah.
So I'm so Saba, are you here? So it's just because I didn't clear my workspace, and then we tried it. And then, so try it, clear your workspace, and then just type that. You will see that it will not count.
All right.
As I said earlier.
All right. When I was doing it, I didn't clear my workspace.
You didn't clear your workspace. So if you don't clear your workspace, it will still be there. Like you can still use. So once you've used the sims like today, you go and come back 30 minutes later. So that's what we are seeing. Go and come back 30 minutes later, you come and use the sims again. Like even if you don't use sims, it will still work out. Okay, so let's move on. Let's someone the question. Can't see. Oh, please, can you see now? Can you see now? Can you see now?
Please. I can
Okay.
see.
Okay, so solving systems of equations. So in MATLAB, what the symbolic math toolbox gives, the advantage it gives to us is that we can be able to solve a number of equations, like a 4x4 equation, a 5x5 equation. We can be able to solve them. Do you get it? So this is the way we do them. So the output is equal to solve equation 1, solve equation 2, solve like the number of equations that are there. Just put all of them there, and then it will do what? And then it will solve them for you. Do you get it? Perfect. So now let's try some questions. Yesterday, I think the question that we used, what was the question? We used some question B yesterday, the one in the slides. Let me open that slide, then we can use that to do it. Duna, talk to me.
You see with the function cos, the inverse of cos, Z is cos E or something.
Is it A cos?
So
A cos.
Yeah, so if you do the sims E, will MATLAB treat it as a variable?
MATLAB will treat it as a variable. MATLAB will treat it as a variable. Once you put sims A there, what MATLAB does is that MATLAB treats whatever thing that you've placed over there as a what? It treats it as a variable. Do you get what I'm saying? Do you understand what I'm saying? Juna? Bob?
Yeah, I get it. Yeah,
if you like, you can use the same equation, but then put a different variable that does not E, and you see that the same answers that will come. Because if it was, let's say, A cos something, then to be A multiplied like A times. But once, because MATLAB doesn't do 3 open bracket 2. It will do 3 times 2. Like, do you understand where I'm coming from?
Yeah.
So now these are the systems of linear equations. 2x plus 5y plus 7z is equal to negative 17.5. 3x minus 6y plus 2z is equal to 40.6. And then 9x minus 3y plus 8z is equal to 56.2. So in this case, we have what? Sims what? X, sims y, and then what? Sims z, right? Perfect. So now equation 1. So now our variable, let's call our variable. Jerry, you have a question? Jerry, go ahead. Jerry, go ahead. Jerry, go ahead. Would the sims character with an operation still count as a variable? Nah, I don't think so. I don't think so. So let's say as in sims A. Oh, okay. After you're done with this question, we'll do that. Okay. After you're done with this question, we'll do that. All right. But I don't think so. I really don't think it will work out. Yeah. So sims X, Y, and Z. So equation 1. Equation 1 is equal to, so equation 1, that's our variable name. That's what? Minus 2x, minus 2 times x, plus what? 5 times what? Y, plus 7 times z is double equal to negative 17.5. Then colon. Then equation 2. Equation 2 is equal to what? 3 times x minus what? Minus 6 times y plus 2 times z double equal to 40.6. Then equation 3. Equation 3 is equal to what? Equation 3 is equal to 9 times x minus 3 times y plus what? Plus 8 times z. That's double equal to what? 56.2. Then I suppress these two. Then the next one I'll do is what? So I put into brackets, what am I looking for? X, y, and what? Z. Then it's equal to what? Solve what? Equations 1, solve equations 2, and solve equations what? 3. So you see, x is what? In that case, x is 16.5, negative 23.5, 17 over 10. And then one thing about MATLAB, what MATLAB does is that in the symbolic toolbox, the symbolic toolbox gives answers as this thing. It gives answers in terms of fractions. You have to activate a function before you can give you the answers as decimals. Oh, I've forgotten the name of that function. I'll check my diary and see. My lecturer told me one time. Did I write it down? Oh, there's a function there. You need to, when you use that function, then you can get this one. Oh, this is really painful. So MATLAB is all about functions. If you don't know the function, you'll not be able to do it. Oh. My boss told me this thing one time. I'm coming.
Is it the float or the integer?
Is that what?
function?
No, it's not an
Is it
integer
the float?
function. Is it a vein what? I know it's something with a vein. Is it a vein what? Did it say vein?
No. I was asking whether it's a float or integer function.
No. What if you see that MATLAB with a symbolic toolbox, what MATLAB does is that it normally gives the answers as fractions. So if you wanted to give the answers as decimals, there's a function that you have to call. When you call that function, the MATLAB will not give you the answers as what? Decimals. Do you get what I'm saying?
Oh,
Do you
yeah.
understand what I'm saying?
Yeah.
Anything that you do
Yes,
is symbolic math, it will always give you the answer in terms of this thing. It will always give you answers in terms of what's the name? Answers in terms of fractions.
Fraction. Okay.
Yeah, let me open activity 2 and see. Should I fit it down? No. Oh, I didn't write this thing down. All right, it's fine. I'll remember. I'll surely remember. So remember we had answers as 3.2, negative 4.6, and 1.7. So 17 over 10 is 1.7. 16 over 5 is what? 1.2, 3.2. Then 23 over 5 is what? What's the name? 4.6, right? So that's somebody just texted. Is it round? No, it's not round. It's not round. It's something that's got to do with a V. I remember. That's why. Hold on. Let me just check on it. It's something that's got to do with a V. The function that expresses answers in symbolic toolbox, symbolic form as decimals. Oh, this one too, you're not giving me it. That's one thing about Google. Don't go straight to the point. It's fine. It's fine. I'll get it for you guys. I know I wrote it somewhere. I just need to revisit some stuff and I'll get it for you. Oh, I remember this thing was. Okay. So we can continue, right? So we used this same function. We use this same function. And then you see that we had the same answers. Do you get it? So you see how simple the symbolic toolbox, like you see how it makes life very easy. See how the symbolic math just makes life easy. We just input this and this and that, then we are done. But metrics, you now have to come and do. So let's say it's a 10 by 10 equation. Just input all the equations, solve these equations, go. So you see, life is very, is it VPA? Yes, VPA. Thank you very much. Tonight is VPA. Thank you very much. Yes, it's VPA. It's VPA. It's VPA. Thank you so much. Yeah, VPA. Thank you, VPA. I'm coming. So X, so let me redo this. So X, Y, Z is equal to VPA, open bracket, solve, open bracket, equation 1, equation 2, equation 3. Too many input arguments. Coming. Okay, it's fine. It's fine. Coming. Let me just try this. Because I know it's VPA. Yeah, it's actually VPA though. Now, just doesn't work that way. Okay, let's continue. But I know it's VPA. I know it's VPA. Oh, let me do this. VPA open bracket X. Or VPA open bracket X. So after you get the answers, they just use VPA to get like X, Y. No. Let me do this. VPA X, Y, Z is equal to solve open bracket equation 1, equation 2, and equation 3. Okay. So when you're done getting the answers, then you just do VPA of X. Let's say you want to show it in decimals. So VPA of X, VPA of Y, and then VPA of Z. Yeah. Jonathan, thanks. Yeah, Jonathan, thanks. Yeah, that's my project supervisor's. Yeah, that's my project supervisor's student. So the doctor mentioned it to you one time.
Well, he's a shark himself, but
yeah, I
Juna, I know it's a shark. Hey, Juna, in present, Charlie, there in more pass. Who the more pass you now?
Let's continue. I beg.
Let's continue.
Yeah, let's continue. Juna, present. Oh, Juna, there, it's a shark. I know him already. So let's try this example here. Hey, let's try this example here. Don't come and act like we don't know you. Let's try this examples here. So we can do this example. Or this example are not so friendly. They are not so friendly, but it's fine. So Sims X, Y, and T. Then A is equal to, we have 10 star what? Star X plus 12 Y, 12 times Y plus 16 times T. Great. Then B is equal to 5 star X minus Y minus 13T. And then it says solve for what? Okay, so now XT, YT. So solve for XT, solve for YT. That's equal to solve open bracket A, comma B. So that's one thing about symbolic math. You can just use it to solve systems of linear equations. Okay, next one. So the next one is differentiation. So we'll do differentiation, we'll do integration, all these, then we are done. Okay. So that will not take much time. So when you want to do differentiation in symbolic math, what happens is that we use the function called diff. We use the function called what? Diff. D-I-F-F, diff. And then I'm sure in integration, somebody will be like, so use int. Yeah. So in symbolic math, when we want to differentiate, we use diff. When we want to integrate, we use what? Use int. Do you get what I'm saying? Perfect. So that's how we do it. So the same way, but then this time you have the chance to specify the variable. That's if you have, like, let's say 2 or more variables that are supposed to differentiate. So let's say differentiate this with respect to y for me. You get the answer. So let's go with one variable, sims x. So y is equal to, somebody should give me something. So let's say change x, change x times x cube plus say 3 cos 3 cot x times exponent minus 3 times x squared. So yeah, we have this. Let me just put this in brackets to show that these are together. And then this also together. So those of you who are in first year learning this, you have an advantage. Like when you want to do your differential equation, you want to get your graphs, you can just use MATLAB. Okay, so we have this. So now we want to solve, I want to get the differential of this. So diff what? Diff y. So this is our answer. So of course, when you differentiate signs, you get cos. So they are done, they come in. So this product, so you differentiate, so you actually leave this as a constant, you differentiate this, you leave this as a constant, you differentiate that. So you get 3s squared cos s. Then when this is a constant, 3s squared, perfect. So no problem at all. To do it for you. The integration, the same thing.
Yes.
So you want, yes.
I beg Laplace.
Laplace. I've not explored up to Laplace, but I'm sure there should be something like that. People are looking for ways they can make lives easier for themselves. I'm sure there should be Laplace. I'll check it out. Thanks. Yeah. So I'm sure there should be Laplace. I'm very sure MATLAB could do all of this stuff. Yeah. People are looking for ways to make life easy for themselves. So you can do differentiation, then integration. So integral. So let's say you want capital Y. So capital Y is integral of what? So int what? Int y. So you see, integral y, everything has come. So let me read through the slides. So you just need to know the functions, diff x and then what? Diff and then int. But then one thing is that when you have multiple variables, and let's say you want to differentiate something with respect to one particular variable, then with that, you have to specify the variable. So we'll get there. Okay. Somebody should give me an expression. So let's say we have sims x, y. Great. Then we have 3x plus 5y. Let's give some simple expression like this. Divided by 4x minus 2y. So times, then that. So let's say this is z, right? So now we have two variables. If you want to differentiate, what we have to do is that what? We have to differentiate with respect to something. So differentiate z with respect to what? X. This is your answer. Then differentiate z again with respect to y. So you see the answers are different. As you see, the answers are different. When we differentiated z with respect to x, you can see the answers are different when we differentiated z with respect to what? Y. Do you understand? How? Oh, somebody asked a question. Obviously, Fala. Somebody wanted to ask a question. Yeah, please go ahead.
My question is with regards to the integration. What if you have limits? Let's say there is a limit.
You can input the limit. you can input the limit. It will give you the answer
How
straight
do you-
away. We'll do that. We'll get there. We'll get there.
Okay.
Yeah. So as you can see, symbolic integration can be carried out using the int command. The command can be used for determining indefinite integrals. That's antiderivative and definite integral. So Sammy, I hope you are fine here. So let's say, so integral that with respect to the particular variable, lower limit, upper limit. Do you get it now? You see? So lower limit and upper limit. Oh, okay. So integration 2 is there. So let's say we want to integrate. So let's say Jane, the first one, integrate and open brackets into what? In z, x, comma, lower limit 1, upper limit what? 2, close bracket, enter. So you see the answer. Piecewise function. You can see. So somebody could just go. So h is equal to int open bracket z, comma, y, comma, 1, comma, 3, close bracket. So these are the things that MATLAB can do for you. It can do a lot of this stuff for you. Do you get it? So that's with a symbolic expression. So imagine I taught symbolic expression yesterday. I say, is there a way to find total differential ones? I mean a single function. People want to make life easy for themselves. I'm coming. Please let me text the executive so that they could get us the attendance form. I'm coming. Let me text them so that they could send me the attendance form quickly. So they say knowledge is power. Knowledge is power. Do you get what I'm saying? If you don't know some of these things, you'll be using your mind to do a lot of things. Then you go and pay this Symbolic and they'll chop your money free a month. Now, how much is it a month? I think it's a lot of money, right? Now, how much is it? Those who have subscribed to Symbolic, how much is it? That phone app that helps you solve questions. And even that one, there are some questions that you can't even solve. How much is it? There's somebody giving the price. It's a lingas power, massa. Boys. So come here, I'm texting the guys so that they'll send me the attendance. Okay. All right. Okay, that's fine. So yeah. So I'm putting it there. I said they use free mode, Pew. I said, oh, God's Mass is free. Oh, okay. Hey, so people have apps solving things for them. Wow. The attendance. I'm typing the attendance in the chat. So please let's fill the attendance. The attendance is there, so let's fill it. The attendance is there, so let's fill it. Okay. Yeah, so I'll check. So Jonah, remind me, I'm supposed to check the Laplace for you. So tomorrow, before anything, I'll give you feedback on the Laplace form. And then also there are some, I told you guys yesterday that there are some extra stuff that I wanted us to do with the matrices and all, like how to do those characteristic polynomial eigenvalues, like just solve examples on them so that we can be fine with it. So vectors and matrices 2.1. By tomorrow, we should finish that. Then we'll move on to differentiation and integration. Okay.
Blues.
Yes, please. Talk to me.
I don't know if it's only me, but then they're saying the form is accepting no response.
It's not accepting response.
It's not you.
Okay. Okay. Then I think, okay, I just went to my chat. Hold on. I went to my chat to get, he has sent me this attendance form sometime back. So I just went to pick it up. But he has not yet gotten back to me right now. So I'm waiting for him to, when he gets back. Okay, he's typing. He's typing in my name. So let's wait. He's typing. Okay, he has gotten back to me. So let me just copy the link and paste it. Okay, so I'm sending a new link. The new link for attendance. Okay, please try it quickly and let's see. Try that quickly and let's see if it works out.
Yeah, it works. It works.
It works. We thank God. Let's move on. We thank God. Let's move on. Okay, so let's finish the class. Let's finish the class. Let's finish the class. So the next part is solving an ordinary differential equation. Solving an ordinary differential equation. So now when you want to solve differential equations with MATLAB, what happens is that you have to use the word, you have to use the D solve. This time just add D to the solve so that it just shows that what you are solving something, like you are solving the function, like you want to solve this as a differential function. Do you understand what I'm saying? And then this time the way you input your variable to change. Do you get what I'm saying? Okay. So like let's say we have a function. Okay, I have a tutorial here. Let me go back and open that tutorial. Then hold on. Great. Let me open this. Okay, let me go back and open tutorial 9. Okay, that's tutorial 9, right? Okay, so we can use this. So let's solve this question. So determine the general solution of the equation dy over dx is equal to e raised to the power y cos what? Cos x. Perfect. We'll come to that. We'll come to that. Okay, so let me go back and finish this. Okay, so when you want to do this, use the dsolve command and then dsolve the equation and then the variable the way you want it to be solved. So let's try this out. Let's try this out. If somebody has asked a question, please zoom. Oh, okay, I should zoom in. Okay. Okay. So this is the expression that we want to solve. So we want to solve dy over dt is equal to what? 4t plus what? 2y. So then this time when you want to input your sims, it's going to be what? Sims of what? Sims of y of t. Do you understand? Sims of y of t. Great. This form only occurs when you want to solve ODEs. This form occurs only when you want to solve ODEs. So sims y of t. Can we continue? Or we can continue now? Okay. So you just input the derivative part. So let's say if it's dA over dx, so sims what? A over x. And if a and x are not part of your, difference, like they're not part of the derivatives part, then you have to add them to the what? You have to add them as symbolic symbols too. I'll come to that. I'll come to what I just spoke about. I know people don't get it, so I'll come to that. So we have dy, so we have this question. Dy over dt is equal to 4t plus what? 4t plus 2y. So now we want to solve this. When we want to solve this, we use the dsolve function. Do you understand? So dsolve, open bracket. So we want to write dy over dt. So dy over dt this time will be what? Def, open bracket, y, comma, t, the first derivative. Do you understand? So meaning if it's d squared y on dt squared, that will be what? Def, open bracket, y, comma, t, comma what? 2. That's d squared y on what? dt squared. Do you get it? And then the equal to sign, double equal to what? 4 times t plus what? 2 times what? Y, right? Then you close the bracket. If you don't have any initial conditions, fine. But if you have initial conditions, you can add the initial conditions. But here we don't have initial conditions, so enter. Hey, please, the person using the marker, I beg you, please. The person using the marker. The person using the marker. So this is our answer. So C1 times e to the power 2t minus what? 2t minus 1. So you see, because we don't have boundary conditions or initial conditions, that's why we are getting what? C1. You understand? But then the second time, I said something that, oh, please, the person using the marker, once again, I'm coming.
Blues.
Yes.
The one you added after the diff, you said is what?
The diff y, comma t, the one.
Yes.
The one means first derivative. Do you understand? Do you understand?
Yeah.
So if it's 3, it means the third derivative. If it's 20, it means the 20th derivative. Do you get it? So you see, for this question, because a and x are not part of the derivative, like the derivative function. So in that case, we'll have to name a and x as what? We have to name a and x as symbolic. We have to name them as symbols too. So sims s of t, then a, then x. Do you understand? So dissolve, open bracket, diff what? Diff s, comma t, the first derivative, double equal to what? A times what? Times x squared. Close the bracket, enter. So this is our answer. Do you get it? Great. So now let's try some examples. Let's try some examples before we go. This is our last thing, then we'll try some examples. Okay. So now, determine, so we have this function. It says what? These are differential equations. We are supposed to solve it. So, sims what? Sims y of what? X. So because y and x are also at the right hand side and they are the derivative part, we don't need to specify them again. So enter. So dissolve. Okay, so z is equal to dissolve, open bracket what? Open bracket diff y, comma what? Y, comma t, comma 1. Oh, please, we'll close soon. Don't go, I beg. Double equal to ex exponent what? Exponent y times what? Times cos x. Do you get it? There you close the bracket, enter. Did I make a mistake somewhere?
Yeah, it's supposed to be y of x.
Thank you. Thank you.
You're welcome.
So x, enter. Great. So z is equal to what? Minus log, open. So you know log in MATLAB means what? Len. So minus len, open bracket, c1 minus sine x, because we didn't add in this one there. The next one says determine the solution of the differential equation that satisfies the initial conditions. So these are the questions. So sims what? So sims y of what? Y of t. Do you understand? Perfect. So now a is equal to what? A is equal to dissolve, open bracket, diff y, comma t to the what? To the second derivative, right? Great. Minus 0.08 times diff, open bracket, y, comma t, comma 1, close bracket. Do you get it? Plus 0.6 times 0.6 times what? 0.6 times t is double equal to what? 0. Are we here? Are we here?
Yes.
We are here, right? Now let's solve this.
Yeah.
Enter. So this is the answer without the initial conditions. You can see this is the answer for E. Now when we add the initial conditions, now let's add the initial conditions and solve. Control C. Comma y of 0 is double equal to what? 2 times the differential of y, comma t, comma what? Y, comma t at 0. So the differential, hold on. The differential of y comma t, that's the differential of t at 0. Do you understand? Do we get it? So y prime, open bracket 0, is double equal to 3. Close the bracket. Y prime of 0 come. Come in. This y comma t comma 1. How do you express this thing? So, no, I don't remember doing it this week. 0, close bracket. More from this. Oh, I'm coming. Hold on, I'm coming. Okay, just differential of 0. It's not working out. Have I made a mistake somewhere that I can't see? I made a mistake somewhere that I can't see. After this, we are done. We are done. Is anybody here going for the Aspen class? Is anybody here going for the Aspen class?
Yes.
Jonah, you are going,
Yeah.
right?
Yeah.
Only Jonah. Okay, that's fine. All right. So yeah, so basically we are done for today. We are done for today. Please, any questions? Any questions? Any questions? Python has started.
I wanted to know if the answer the last part, no, is that the answer?
Yes, whatever, which one? Ask him, the y of 0 is equal to 2 differential.
Yeah.
Are you first year or second year?
I'm in my final year.
Oh, those are the boundary conditions. So you remember initial conditions of differential equation?
Yeah, I remember. But
So,
I'm saying you were like you are looking for the where you made a mistake at.
okay, yeah. So that's the final one. The final one, so the final one that the answer came. Yeah, that's the final thing I was supposed to do.
Oh, okay.
Yeah, all right. Please, are we fine? Are we fine?
Yeah, manageable. Yeah.
He must said manageable. Manageable as in.
I got lost at the point in time, but I know I'll catch up. I'll just catch
Which
up.
part? Which
I think
part?
when we started with the differentiation, the whole of that part.
Second year.
I'm in third year. I just got lost because of some of the syntax, but yeah. But I'll be okay. I'll be fine.
Okay, when you go through them, you'll be fine. For the first time, you'll be lost. So don't worry. So I'll send you guys some assignments to do. So which you got? You got lost that differentiation. Oh, who else got lost that differentiation? Who else got lost there? Please, who else got lost that differentiation? The slides. Oh, don't worry, do all count. Hey, this guy's always on the slides. Hey, Charlie, who else got lost there? Okay, so tomorrow we have to go through I told you tomorrow we'll solve. Jonathan said something about Laplace. He wants life to be easy for him. So don't worry. I'll go and do some small research on the Laplace and see. It has never occurred to me to solve Laplace with MATLAB before. Wow, people are very curious. And then we'll do some vector and matrices. And then tomorrow, because most of you guys didn't get there, you didn't get it again. So I'll use the first 1 hour to go through this one before we start the differentiation and integrating, because it's not really much of a work. Yeah, some 1 hour we should be done. Like the way symbolic math was not really much of a work. So we started a little bit, started like 1 hour, 20 minutes of time. So we'll do that tomorrow too. Is there any question for anybody? So today I can't send you assignments because like, you don't even understand what's going on. You don't really understand much. So I'll send, so just complete the assignment. Then tomorrow, when we use the first 1 hour to wrap up everything, then I'll send you assignments for everything. Do we get it? Do you understand?
Yeah,
Hello,
sure.
All right, thank you very much. Somebody's happy, no assignment. All right. Is there anything else? Is there anything else? Okay, if there's nothing else, then I'm ending the meeting. Yeah, thank you guys so much for your time. Like, thank you for showing up. It's just 11 minutes past 3 o'clock. Like, you are free to go for the Aspen class. Thank you very much. Yeah, bye. Yeah, see you tomorrow, 1 p.m. same time. Yeah.